Let's look at these questions. So first one says use this equation to estimate the age of our universe, and time is just 1 over our Hubble constant, which is 1 over 2.4 by 10 to the minus 18, which gives you 4.17 by 10 to the 17 seconds. So that's how old that equation suggests the age of our universe is. We'll look a little bit more at that in question 2. So it says the extent of the possible observable universe is the distance light could travel in this time. How far is this? So if light was emitted at the point of the Big Bang and it traveled through space for those entire 4.17 by 10 to the 17 seconds, what sort of distance does that equate to that we can look back in time to? So what we need to do is convert that time into years. So we have that the time is 4.17 by 10 to the 17 seconds. So if we divide by 60, that would get that into minutes. Divide by 60, get into hours. Divide by 24, we'd get it into days. And divide by 365, and let's be precise, and a quarter, that will get it into years. And what we find out is that gives us a time of 1.32 by 10 to the 10 years, which is kind of 13.2 billion years. And that's how we think our universe is. And that's the time, but that's also how far light would travel in that time. So light could have traveled 1.32 by 10 to the 10 light years. Okay. How far is this in meters? Well, we just go back to using this initial time, and we can just do speed equals distance divided by time. So light is 3 by 10 to the 8 meters per second. We've got a distance that we're going to get in meters, and we've got our time needs to go back to the time in seconds because this here is meters per second. Rearranging that gives you that the distance is 1.25 by 10 to the 26 meters.